page replacement will be a crucial, because swapping operation takes far much time. It'll take like a 10,000 or 100,000 more time than ordinary memory access. So the number of the swapping should be minimized, because it'll be very crucial to the system performance. At that point we talked, and then now let's talk about some specific policies that current operating system use as for page replacement. And note that these replacement policies are not limited to the paging issue, but it can be found also other issues in managing caches like TLBs and so forth. Yeah. So we will go through 5 of them, as we can find from your textbook. FIFO, roughly speaking, FIFO is what? FIFO means that, yeah, it's the one that you learn in data structure and algorithm class, in the order of their first appearance, in the order of their first appearance. The one that is old here means the one that stay the longest time in a memory will be picked as a victim for replacement. That is FIFO idea. Random is what? Pick anything, pick arbitrarily pages. So these two work as a kind of the baseline algorithm. These are very naive algorithm by which we can identify some limitation of this naive approach, and also see a chance for improvement. And then we will see kind of an optimal algorithm. So this is unrealistic. We will see that this is unrealistic, but it will be like a theoretical bound for best performing page replacement policy. And after that, after seeing these two baseline and ideal case, and then we will see more practical and feasible solution, that is LRU, shortly speaking, least recently used one, and also FU, least frequently used one. In that order, we will check them. And in discussing them, in order to compare two different replacement policy, we need to have some adjustment how good a policy is. So, I mean, assessment in real world system will be really complicated, but in this discussion, we here establish some assumption to make the assessment simple yet effective. So here I set up some assumption. The first assumption is that we here assume that there is only one process running in the system, and this process use all the physical frames. Okay, make sense? Okay, and here in further discussion, we assume that workload can be represented as a sequence of the VPN accesses. I mean, workload can be, more strictly speaking, sequence of the memory accesses, but memory access will be mapped to a certain VPN accesses. So it'll be all right for us to just think about VPN accesses. Yeah. Okay, and we here also assume that page out occurs only when memory is full. Okay, and also the last assumption is that in order to count the time cost for running certain workload, we here count the total number of the page in operation and page out operation. And if the number is high, it means it takes much time. And if it is low, it takes less time. In that way, we will assess how good an algorithm provides in given workload. Okay, so because I mean, in dealing with these three, we need to have another aspect of a page replacement policy, other than the other issues of the paging, other than the replacement policy. So, for example, I mean, dealing with the multiple processes. I mean, policy for dealing with the multiple processes for sharing the same frame is a kind of an independent issue. So we need to establish another policy for orchestrating multiple processes. So we just set this issue beside. So we here bring assumption on simple case. And also Yeah, this is a kind of trivial one, but this one is, yeah. Yeah, page out, as we discussed earlier in last class, page out can be proactively done. However, that is another independent issue. So we don't want to be bothered by that direction. So we just bring simple assumption so that we just assume that page out happen only when page is full. And I mean, the cost for page in and page out will be different. I mean, accurate assessment, accurate measurement of the cost will be another tricky issue, but we just set this issue beside. Because here we only want to dealing with the page replacement algorithm. Fair enough? Okay. 무슨 말인지 알겠죠? Okay, FIFO. FIFO is what? FIFO means page out the one that was paged in first. I mean, the one that survived the longest time at a moment in the physical memory, because the old one is likely not useful. Here, the basic idea is that the one that already loaded before will not be useful because execution context moves on, so that the old one was not being really used in later moment of the program execution. Okay, here's some example of the workload. So this is a time progress, and these are the VPN number. In this example, we assume there are 3 frames and there are 4 pages, named it by 0, 1, 2, 3. Okay, and this is a time progress. And it starts with the 0. And let me show you how FIFO make a replacement in this workload. So for accessing 0, 0 was not there, obviously. Initially, frames are all unused, so initially no pages there. So if a processor try to access page 0, it'll definitely raise page 4. Page 4, and OS needs to bring 0 to this frame. Note that here, this is just a frame. Here, each block just to show you, just to indicate a frame, but there is no ordering or there is no identification of frame number here. I just indicate that page 0 is brought to the physical memory. Okay, good. And then what? Try to access 1. Surely 1 is not in the physical memory, so another page fault happened, so that 1 will be brought, and then 2 brought here. I mean, these 3 page faults are kind of unavoidable thing. It's a inevitable thing, and we call, so when we execute the program, that at very early phase, it will have a series of the page fault, so that it'll take pretty long time for loading all initial pages that program starts to use, right? And for such loading or dealing with the page fault of them, program execution time will be slightly delayed. And we call such phenomena as a cold start. cold start라고 합니다. 그러니까 없는 상태에서 바로 시작을 하니까 cold start를 이제 웜업하기 위해서 처음에 시간이 좀 드는 거예요. cold start라고 합니다. Okay. And there is another techniques that moderate the problem of the cold start, because cold start hinders some responsiveness of the program execution. 그렇죠? 여러분이 프로그램 딱 키면은 지금 쓰고 싶어서 딱 키는데 오래 걸리면은 문제가 되죠, 그죠? 그러니까 cold start 문제를 없앨 수 있으면 좋아요. This can be you can easily think of nice idea for them, because for program we can somehow predict some essential pages to load in initial phase. So in those pages should be loaded without having a first access on it. 그런 거 생각해 볼 수 있습니다. Okay, 0. So now we have a 0 in physical memory, so we don't need to have a page fault. Good. Here the blue colored mean the page faults, the case where it is loaded by having a page fault, but with the only page in. Okay, and in accessing 1, we don't need to have a page fault. Okay? But you see that now we have a page 3. Then we need to demand this request by bringing page 3, but the memory is full. then which one is to be evicted? The oldest one, which one it is? 0. 0 is the one that brought first to the main memory. Not main memory, physical memory. So 0 will be evicted out, page out, and the page 3 will be brought in. So I color here it red by showing that this requires page out and page in. The blue color here so far means only page ins because there were no pages to be sent out, write out. 그렇죠? And then what? We have a 0 again. It's a kind of a worst case situation. Okay, to bring 0, which one is to be evicted? 1, yeah. Yep, in that order. And 3 can be served without page fault. Which one is to be evicted? Now, this one is the oldest one among the one that is in the physical memory. So we should page out 2 and bring page 1 again back to the physical memory. No problem in serving this request, but we need to have a page 2 again. So among these 3, we'll see that this one was the furthest in loading these pages, so that the page 3 will be written out, and then page 2 will be brought in to the physical memory. And for the last moment, we have another access on page 3, which requires one more page in and page out. So how many page in and page out happen in running this workload with the FIFO? 1, 2, 3, 3, and here. So these are only 3 page in. So let me only count the page in. 3, 4, 5, 6, 7, 8. 8 page in. And how many page out? 5 page outs. So total 13 page in or out operation happen in running this workload. Okay. So what do you see from this example? I mean, what kind of a limitation or kind of a problem people have as you see in this example? 뭐가 문제인 것 같아요? I mean, this workload is not realistic, but by checking this one, you can think about kind of a limitation of idea of FIFO, idea behind the FIFO strategy. People here assume that the old page will be likely not useful or will be likely inactive in future execution. And do you really agree on that idea, or do you see any problem on that idea? So FIFO idea here assume that the intuition behind the FIFO is that the old pages will not be useful in later moment of the program execution. And do you see any problem in that idea? I think there's some problem. Well, I want you to think, to point out the problem. Yeah, good points. I mean, page that is frequently used will be accessed early moment and continuously be used. So if only FIFO works, then the frequently used page will be recognized as victim frequently. But those need to be brought again back to the physical memory frequently, which incurs unnecessary overhead of page in and out those frequent pages. 그렇겠죠. 자주 쓰이는 페이지가 있단 말이에요. I mean, Yeah, and if because that is likely happen in ordinary application program, because we write the program in that manner. So for example, if you wrote a program and your code was spread over multiple pages, and some of the pages contain some functions that are frequently used, right? And some functions are frequently used and some are less. But if you, for the pages that are frequent, that contain the function frequently used function, it will be accessed early moment, maybe from the very beginning of the program execution, and reside on a physical memory, and then it will be continuously brought to the, continuously used over the time. But since it was accessed from early moment, it will be checked as a victim. It will be found as a victim of the page replacement feature. So if there are some like a frequently used pages, then default idea doesn't work nicely, and that is the case of an ordinary application program. So default idea are rarely used in actual system. Make sense? Okay, good. Okay. Another baseline algorithm is a random. If we use some algorithmic strategy, and if it has, the algorithm have kind of a limitation, then yeah, these type of the algorithmic policy, algorithmic heuristics will have some kind of a weakness, and some kind of a counter example that make a system poorly perform. However, once we use a random algorithm, it kind of avoids the trivial weakness by probabilistic chance. So the performance will be later more robust than poorly designed algorithmic. So here the idea is pick any page that is in the physical memory as a victim for page replacement. So there can be various scenarios that go with this workload example, but let me show you one of an example. These three cold start problem is kind of an evitable thing. So unavoidable thing. So these three page fault happen, and suppose that, yeah, paging go in this way. So in order to serve this request, we need to page out one of these three. Which one? Anyone. But in this case, happened to be the second one was picked. So here, yeah, page 1 was sent out, and page 3 was brought in. And in this way, yeah, in here we need to serve this one by evicting this one. And for example, happen in this way. How many page in and out happen in this case? 1, 2, 3, 4, 5, 6 page in and 3 page out. Yeah, this is just one case. And there will be other case, and there will be a case where, yeah, far larger number of the pages in and out happen by chance. But in average, I see that, yeah, random policy provide a better performance than FIFO, I guess. 네, 왜냐면은 FIFO, yeah, is designed to select frequent page as a victim, but random algorithm has no intention for that. So frequent pages have a less chance to be selected at page replacement. So I guess if a workload have a tendency of having some frequent pages and infrequent pages, random policy provide a better performance by preventing frequent pages to be evicted at the page replacement.